Now we are going to understand the whole concept with the real life mathematical models. So today I have considered these two things as the planes in three-dimensional space, and as usual this gorilla tripod as our Cartesian coordinate system. This is x-axis, this is y-axis, and this is z-axis, and this is the origin. Now our objective today is to find the distance of a point in the space from a given plane. So we have to find this much distance, this distance from this point to this plane. So first we will imagine another plane, imaginary plane through this point like this. Suppose this plane is passing through this point and must parallel to this plane. Why we are taking parallel planes? Why we are considering parallel planes? That I will tell you shortly. So now, suppose equation of this plane is r vector dot n cap equal to d. That is the equation of a plane in normal form. What we have discussed in our previous lectures, maybe lecture number 20. Go through the playlist of my channel SSD capsules, then you can get it. Now, what is the significance of n cap? N cap is nothing but a unit normal vector to this plane. Normal vector means this vector, if it is n cap, then n cap must be perpendicular to this plane. And what is the significance of d in the equation of this plane? D is nothing but the distance of this plane from this origin. So this much distance is d. Now we have considered these two planes are parallel, right? Why? If they are parallel, as they are parallel, this n cap is perpendicular to this plane. Now, as these two planes are parallel, so this n cap vector also perpendicular to this imaginary plane also, which contains our point from which we are going to find the distance of this plane. So now we have got a unit normal vector perpendicular to this plane. Also, this given point, suppose this given point has position vector with respect to this origin, that Cartesian coordinate system is a vector. Now we have in our hand that this plane passing through a given point and perpendicular to a given vector. Again we are going to use the concept what we have discussed in our previous lecture, which I illustrate by these mathematical models. You just go through the playlist and you can easily get the thumbnail with these models. So you just go through this lecture, then you can understand what I am telling about. So this plane is passing through a given point with position vector a vector, and normal vector to this plane is n cap. So what is the equation of this imaginary plane? R vector minus a vector dot n cap equal to 0. So now if we just simplify this r vector minus a vector dot n cap equal to 0, we have in our hand r vector dot a vector equal to a vector dot n cap. So if we compare this equation with this plane with r vector dot n cap equal to d, then d is here in our hand, we get d equal to a vector dot n cap. Now this d is the distance of this imaginary plane from the origin which contains the required point. So we have in our hand this much distance. So distance of this point in the space from the origin we have in our hand, which is a vector dot n cap. Also we have the distance of origin from this plane, which is d. So what is the required distance? That is from this point to this plane, obviously d minus this much distance. So we have to subtract. So d minus a vector dot n cap is the required distance of this point in the space from this given plane. That is the main trick behind this whole theory. So now we are done with our beautiful mathematical models, and now we are going to see the whole proof in our blackboard. So go to the blackboard.